Hello friends, in this video session we are going to solve one problem on nodal voltage method. The nodal voltage method is nothing but nodal analysis. Here is the example. Use nodal voltage method to find the voltage of node M and currents I1, I2 and I3 in the circuit of figure. This is the circuit given. We have to find voltage at this node M and we have to find currents I1, I2 and I3. This symbol here indicates that it is an AC voltage source. Now let us go for solution of it. In this circuit, first you select a reference node. Generally, the node where more number of branches are connected is selected as reference. At this point N, these three branches, one from this voltage source, one from this vertical branch and one from this voltage source is connected. So let us take point N as a reference. So let us mark it as a reference. Remember, in nodal analysis, we apply KCL at those nodes where voltages are not known. So, let us find what are these points. Consider this point, which is a junction of this voltage source and this branch. Between this point and reference, one voltage source of 100 angle 0 is directly connected. So, voltage at this point is 100 angle 0, which is known. Since voltage at this node is known, we will not apply KCL at this point. Consider now this point. Between this point and reference, this voltage source 50 angle 90 is directly connected. So, voltage at this point is 50 angle 90, which is known, so we will not apply KCL at this point. At this point M, no voltage source is directly connected between M and reference, so voltage at point M is not known. Thus, we apply KCL only at this node. Also, note that this value 20 angle 53.1 indicates neither a pure resistor nor inductor. It indicates a series combination of resistor and inductor. This is inductor because this angle here is positive. Same thing is here. This 10 angle 36.9 degree indicates that it is a series combination of resistor and inductor. Inductor because this angle is plus, but this value 5 angle 0 indicates that it is a pure resistor. Angle 0 indicates it is a pure resistor. Now let us apply KCL at node M. At point M, we find that I1 is the incoming current, I2 is also incoming current, but current I3 is leaving node M. So, the total incoming current at M is I1 plus I2 and the total outgoing current is I3. So, KCL at M gives total incoming current I1 plus I2 is equal to total outgoing current, which is nothing but I3. Say this is equation 1. Now, let us express I1, I2, I3 in terms of voltages. For that, say that this voltage here is Vm. Then current I1 is expressed as, since I1 is the current flowing through 5 angle 0, one terminal of this 5 angle 0, this one is connected at 100 angle 0 and the second terminal is connected to Vm. So current I1 is expressed as 100 angle 0 minus Vm divided by 5 angle 0. So current I1 is equal to 100 angle 0 minus this Vm divided by 5 angle 0. Now for current I2. Current I2 is the current flowing in this branch of 10 angle 36.9. One terminal of this branch is connected to this 50 angle 90 and the second terminal, this one, is connected to Vm. So the potential drop across this will be equal to 50 angle 90 minus Vm divided by this value, that gives me current I2. So we get I2 is equal to 50 angle 90, this value here, minus this value Vm divided by this value 10 angle 36.9 degrees. Now see current I3. I3 is the current flowing in this branch, which is 20 angle 53.1. One terminal of this branch is connected to Vm and the second terminal is connected to point N, which is reference. So the potential difference across this branch is Vm minus 0, reference 0, divided by this value, that gives me I3. So we have I3 is equal to Vm minus 0 divided by 20 angle 53.1. All angles are in degrees. Let us say combinedly all this is equation 2. Let us now put values of I1, I2, I3 in equation 1. That is using 2 in equation 1. I1, this value will be here. So it is 100 angle 0 minus Vm divided by 5 angle 0 degree. This is the value of I1. Now I2 plus 50 angle, this is 90 degree minus Vm divided by 10 angle 36.9 degrees. This is the value of I2. Now this is I3. So is equal to I3, which is Vm minus 0, which is nothing but Vm divided by 20 angle 53.1 degree. Now this equation is totally expressed in terms of Vm. So solving this equation, we get the value of Vm. Now let us combine Vm terms together and all constants on the other side. So if we take this Vm here, it is minus, this minus Vm, I take it common, Vm bracket 1 upon this 5 angle 0 plus this is Vm upon this, Vm is taken common, so it is 1 upon 10 angle 36.9 degrees. Vm, if I take this term on this side, it will be again minus, so it is plus 1 upon, we have taken minus common, 20 angle 53.1. is equal to, now we have to take these constants on other side. So 100 angle 0 divided by 5 angle 0, when I take it to this side, it will be minus, so it is minus 100 angle 0 divided by 5 angle 0. Similarly this term, when I take it to this side, it will be minus, so it is minus 50 angle 90 divided by 10 angle 36.9 degrees. Now this minus sign and this minus sign, it will get cancelled. Using your calculator, this bracket value can be calculated. Let us pause this video here and try to calculate it. When your calculation will be over, then start the video and check the value I given. Now this bracket value comes out to be Vm bracket zero point 1000 is equal to, again you have to use your calculator and find this value. This value comes out to be 23.002 plus J 3.998. Therefore, we get Vm equal to 23.002 plus J 3.998 divided by 0.3099 minus J 0.1000. Again, it's time for calculation. Pause this video here and calculate this value. Once your calculations are over, again start the video and check your answer with my answer. It comes out to be 63.436 plus J 33.368 wholes. If we convert this rectangular number into polar number, it is equal to 71.677 angle 27.745. So, we have got value of Vm, which is asked here. It is also asked to find I1, I2 and I3. Once we have Vm, then Vm can be substituted here to give value of I1 or I2 or I3. So, putting this value of Vm in equation 2, we get I1 is equal to 100 angle 0 minus Vm. Either I can put this rectangular value or I can put this polar value here, minus, let us put this value, this is 71.677 angle 27.745. all these angles are in degrees. This is the value of Vm divided by 5 angle 0. Again you have to use Calc to calculate this value. This value comes out to be 7.313 minus J 6.674. If you convert this into polar form, it is 9.9 angle minus 42.383 amperes. All are in degrees. Similarly, we have to calculate I2, 50 angle 90 minus Vm. Vm is nothing but either this value or this value divided by 10 angle. So I2 is equal to 50 angle 90 minus, let us put this value, 71.677 angle 27.745 degrees divided by 10 angle 36.9 degrees. Again, use calculator to calculate this value. You will get I2 is equal to you will get this value as minus 4.074 plus J 5.139 in polar form, it is equal to 6.558 angle 128.4 degrees amperes. Similarly, if you calculate I3 is equal to Vm divided by this. Either put this value or this value again. So I put it directly, 71.677 angle 27.745 divided by 20 angle 53.1, that is equal to, again you have to use your calculator and find this value. This comes out to be 3.24 minus J 1.54, and in polar form it comes out to be 3.584 angle minus 25.36 years. Our problem was to find Vm. So this is Vm, this is one answer. It was asked to find I1, I2 and I3. This is one more answer. I2, it was asked. I3, it was asked. I hope this problem is clear to you. Whatever calculations I have given it to you to perform yourself, at the end of this video clip, I have given how to perform these calculations using your calculator. Thank you very much. In the previous part of the video, we have seen some complex calculations. Here, we will see how to perform it by using calculator. The first calculation, complex calculation we have seen in the previous part was in this calculation, this 5 angle 0 or 10 angle 36.9, these numbers are in polar form. In the calculations where polar numbers or rectangular numbers are involved, then calculator must be operated in complex mode. So first, see how to operate calculator in complex mode. We find that second number is complex. So if I press 2, you will get here complex. Complex word indicates that calculator is operated in complex mode. Also here we find that all angles here, angles are not mentioned whether in radians or in degrees, but by default these angles are in degrees. So don't forget to use calculator in degree mode. For degree mode, procedure is shift, setup. We find 1, 2, at third position there is a degree, so I press 3, and we find that here D letter comes. So now calculator is operated in degree mode, it is in complex mode, so calculator is ready to perform any complex calculation. Here my problem is to find the value of Vm. To find Vm, first we have to solve this bracket, then you have to solve this bracket. So let us go for solving this bracket. If you want to solve this bracket, procedure will be like this. First I enter this bracket here. Then this is a division of two numbers, so I place this division symbol. Numerator is to be entered, it is 1. Denominator is 5. Angle 0. Angle is entered by using this key, but it is operated along with shift. This angle symbol appears 0. So first number is entered plus. Similarly, you have to go for second number. This 1, 10, second number is entered plus third number, again division symbol, 1, 20, angle 53.1, bracket complete, is equal to. We find that this part is real and some numbers are there on this side. This arrow indicates some numbers are there on this side. If you want to see these numbers, you have to press this right key. If you want to see the total answer at one time, then press S to D. Here I get this part is a real number and this I indicates that this is imaginary. If I approximate this number to 3 digits after this decimal point, this will be 0.3099. 9 is there greater than 5. So 9 will become, so this will be 0.309 minus J 0.100 equal to. Now we have to calculate this number. First I clear the screen. Bracket, division symbol, 100, angle 0 divided by 5, angle 0, first number is entered, plus division 50, angle 90 divided by 10, angle 36.9. Second number is entered, complete the bracket, equal to. To see the answer, total answer, I press S to D, we get 23.002 plus J 3.998. If I want the value of VM, then this bracket must be divided by this bracket. So VM is equal to it is a division of two numbers, so I press division symbol, enter this value 23.002 plus, normally in Calci this J will be placed at the end of the second number, plus 3.998. I is here, so it is shift I appears here, divided by 0.309 minus 0.100 I equal to. If I want to see again the total answer, then this is 63.593, this is 6 and this is 2, I approximate to 3, plus 33.519, and this I is here, indicates this is J. Now this number is in rectangular form. Suppose I want to convert this into polar form, then the procedure is this answer first is stored in answer position, then shift complex, I get number of options here, this 3 is r angle theta. So if I press 3 here, this answer will get converted into r angle theta, that is nothing but polar form, equal to. Again, if I want total answer, I press S to D. So this is equal to 71.886 angle 27.793 degrees. One more calculation is involved in the previous part of the video. It was I1 is equal to 100 angle 0 minus Vm divided by 5 angle 0. It is done like this, equal to 100 angle 0 minus Vm. Vm is nothing but either this value or this value. If I use this value here, then it is 100 angle 0 minus 71.886 angle 27.793 degrees divided by 5 angle 0. Numerator, there is subtraction of two numbers, so it's better if we separate these two numbers by brackets. Now it is a division of this complex number divided by this complex number. So I press division symbol. We have to enter first value 100 angle 0 bracket complete minus second bracket 71.886 angle 27.793 bracket complete. I entered both the numbers. Yes. Now it is divided by 5 angle 0 equal to, I am not able to see the total answer, so I press S to D. I get answer as 7.281 minus J 6.704. If I want to convert this into polar form, then store this in answer position, shift complex 3 equal to, if I want to see the total answer, again press S to D. It is 9.897 angle minus 42.635. One more calculation which we perform in the video is I2 is equal to 50 angle 90 minus Vm divided by 10 angle 36.9. Again it is done on the similar lines. First I clear the screen. I separate this number by this number. I can use this value of Vm or this value of Vm. So go to calculation, division symbol, first bracket 50 angle 90 bracket complete minus bracket Vm of this value or this value. If I use this value, it is 71.886 angle 27.793 bracket complete divided by 10 angle 36.9 equal to. If you want to see the total answer, again S to D, that gives me answer in rectangular form. It is minus 4.096 plus J 5.136. If I want this in polar form, then store this in answer position, shift to R angle theta is at 3 position, so third equal to S to D, that gives me 6.569 angle 128.571. One more calculation we performed was I3 is equal to Vm divided by 20 angle 53.1 equal to, again Vm, I can use this value or this value. If I go for this again, it is 71. First I press division symbol, then I enter this value 71.886 angle 27.793 divided by 20 angle 53.1 equal to, if I want to see the total answer, it is 3.249 minus J 1.536. If I want to convert this answer into polar form, then store it, shift 2 3 equal to, it is equal to 3.594 angle minus 25.307. So whatever calculations we have done in the video part, I have shown it here. Once you understand the technique, these calculations are very easy to perform. I hope these calculations are clear to you. Thank you.